boys and girls. This is Mr. Kizik, and in this video we're going to be looking at a mid-segment of a triangle here, in the triangle mid-segment theorem. So what is the mid-segment of a triangle? The mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangles. So in this example here, line segment DE would be the mid segment because, as we can see by the markings, D is the midpoint B, E is the midpoint BC, it's connected, DE is the mid-segment. So the theorem states this: if a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and it's half as long. Now, there's a proof that we can do here for each one, but we're not going to do that right at the moment. So if I just look at the diagram above, as we said, line segment DE is the mid-segment of triangle ABC. Therefore, line segment DE is parallel to segment. That's right, AC. And DE is equal to half of AC. Now, I'm going to rewrite this here. 2DE equals AC. Because we get to the algebra part, that'll just be a whole lot easier to work with than with a fraction. All right. So with number one here, identify all pairs of parallel segments. So here, let's say we have XY. XY would be parallel to what in this triangle? It would be parallel to QS. How about XW? What would that be parallel to? Oh, RS. And then what would WY be parallel to? QR. Okay. Number two is the same concept. Number three, if L, M, N are all midpoints of the sides, we got PR is 46, so the whole thing here is 46. PQ is 40. LN is 17. Then I want to find the missing parts. So LM. What's LM going to be? Well, LM is going to be 23. Why? Because LM is the mid-segment in my figure here, and it's going to be half as long as its side it's parallel to. Likewise for MN. MN is 20 because it's parallel to that longer side there, and it's half as long. So that's what we said, 23. We got 20. Okay. What's QR going to be? QR is actually going to be 34 because they gave you LN, which was the mid-segment, 17, and that's parallel to QR, and it's double that size. What's MR going to be? MR is going to be 17. Why? Because if M is the midpoint, as it says here in the problem, that means QM and MR have to be the same. So what half of 34 is 17. And if you notice here, if I just do this bottom right angle, and R is 23, notice I will have 4 triangles that are the same there within my triangle, just oriented all differently. Number 4 is the same concept because number 5. Let's see what's the rest here. As it freezes on me. All right. Number 5. It says find the value of x, and it's the same concept for the rest, except if it's asking you to find a side here, then you just got it. So how would I set this problem up here? Well, we would say this is the mid segment, and then this side is what's parallel. So what do we know from what we talked about before? Well, we know that this right here is mid segment is half as long as this side. That's why we wrote this up here before. 2 times the mid segment is equal to that parallel side. So 2 times the mid segment, so 2 times 7x equals that third side, or the side, 17x minus 18. So 14x equals 17x minus 18. Subtract 17, so I get negative 3x equals negative 18, so x equals 6. And in this case here, that's all the problem. Same concept number 7. Which is the midsegment here? It's DE. So I'm going to take 2 times 4x plus 1 is equal to 11x minus 25. So 8x plus 2 equals 11x minus 25. I can have 27 equals 3x. X is going to be equal to 9. But I'm not done yet because what does it want? It wants DE, so I just plug in 9 for DE. 4 times 9 plus 1 gives me 37 as my final answer. Right. Now, what do we do with the angles here? Because if you recall, we didn't talk about the angles, but what does it do? Using all those angle relationship pairs that we've talked about, we can figure out all the angles in my triangle here. So I look at number 10. Well, what thing we could talk about? We know, where I just highlighted right here, what's the relationship between those two angles? You'd be correct in saying that that is a linear pair. So I could do 180 minus 127, and that gives me 53 degrees. So it's 53. Okay. Now you might be thinking, well, does that mean angle 4 is 53 degrees? Now we don't know that. Nothing says that these triangles are broken down into isosceles triangles. But the other key concept we have here is what we talked about before. Not only are the midsegment and the other side, the midsegment is half of it, but those two sides are parallel to each other. So if I drew a little thing here to the side, here's my two they're parallel, and I got a transversal that cuts through it. What do we know about this here and this here? In other words, angle 1 and angle 2. We know they are the same because they are corresponding angles. So angle 1 is also 53 degrees. Which means the same concept here. If this angle is 59, what does this mean? This angle here, angle 4 has to be 59 degrees. Now, how can we figure out angle 5? Well, we figure out angle 5 by saying 5 and 4 are 180. 180 minus 59 equals 121. Notice too, I could have figured out actually 5 first, because what's the relationship between 59 and 5, and the same concept with angle 1 and 127? They are same side interior angles, right? Here and here. So they add up to 180. So we could go about it. Now, there's a lot of misconception that angle 3 must be 127, say, because students say, well, 127 and 3 are corresponding. That's not the case, because what is angle 3 created by? Angle 3 is created by both these lines here coming together. So there is nothing parallel about that. So how do I find angle 3? Well, what figure do I have? Yeah, that's right, I got a triangle. So I know angle 2, I know angle 4, 53 and 59. So subtract that 180. 180 minus 53 plus 59. Add together, and it's going to be just doing some mental math. 112, 68. My mental math correct? I'm sure you guys will tell me if I'm wrong. Right? And the logic stays the same for like the operator. So if I look here where these angles are pointing to for number 12, right here and right here, what's the relationship between those angles? They are corresponding, so set them equal. 7x plus 4 equals 10x minus 11, and I solve for x. 15 equals 3x, x equals 5. In this case, that's all they wanted you to do. Again, if they asked you to solve for an angle measure, you would just plug it in. And that, ladies and gentlemen, is how you do or how you work with the mid-segment of a triangle theorem. So remember, if you have any questions or concerns, please feel free to message me. This is Mr. Cusack, sign off.